guys, this is Eduardo and Rodolfo. So today we're going to be learning about the periodic table. It was created by a gentleman named Mendeleev, Russian. So what we're going to describe today are some of the
Compounds.
compounds, some of the elements, the meaning behind each section of the periodic table,
And what they are.
and then some of the trends that the periodic table
Includes.
includes.
Alright, so we have the noble gases, the alkali metals, the alkaline earth metals, the transition metals, the metalloids, and the non-metals.
So on the noble gases, most of them all of them use the rule of 8, except for helium, which is 2. All of them are very stable, and they require more energy in order for them to be split. And they lie to the right of the periodic table. To the left of that, we have the nonmetals, and they're characterized by not being metallic. Then we have something that it's in between the elements that are metallic and non-metallic, and they are called
Metalloids, that's right. Metalloids. Goes down like that. So metalloids.
some examples are beryllium silicate,
Silicon.
and more examples. Towards the middle, from the metalloids on left, we have the transition metals, and most of them are
We have iron.
hard, shiny, things like iron, things like nickel, gold, and they're usually metal. They're hard, they're
Silver.
shiny,
They're solid.
they're solid. Do you want to continue with the alkaline earth metals? Okay, so the alkaline earth metals are to the left of that, and then we have two groups: the alkaline earth metals and the alkaline metals. More to follow on that.
So we have
So now we're going to describe some of the trends within the periodic the periodic table, but it's really natural phenomena that happens to elements. So, and their patterns in relation to the chart or the periodic table. Electronegativity. That is when you go from this side of the table on that way, the electricity or the electronegativity increases. The atomic radius speaks of the size of the element, and the energy required to make it share or split. So the further right and up,
they're more compressed.
they're more compressed, and it takes a significant amount more energy to make them separate.
I'm pretty sure that's ionization energy. When it
Okay.
takes more energy to remove an electron. Right? I'm pretty sure. They're very compressed. Like it's composed of 7 electrons, and it's like you said, they want that 8th electron. They're very compressed, and they want to be put. They want to reach that A mark. And then the metallic character, that's the one that.
So as you go
That's the coffee.
from right to left, and in this general direction in the chart, it's the more metallic. All of these are gaseous at room temperature, or they're non-metal at room temperature, and the further left you go and left and down as you go, the harder or more metallic-like that the elements become. With the ionization energy, as well as with the electronegativity,
Yeah.
both of them have the same pattern because
Yeah, it's electron.
Just like Eduardo
electron
was saying.
affinity. Electron affinity and electronegativity is the one that have the same related pattern, as you can see.
So they both mean similar, or they have the same?
They have the. I mean, they have the same directional patterns because they're very, very similar. But the ionization is like I had explained with the you know, like needing more energy.
To make them
Yeah.
split up, as opposed to the stuff that's more metallic, which are usually bigger and easier to break apart. So far, so good. Okay. Game. Blouses.
I like how we didn't even